Okay, hi everyone. So find a power series function satisfying the derivative is again the same function. And if I plug in 0, I get 1. Okay, so the idea is guess the form of the solution. So in other words, I guess I'll say that when confronted with the differential equation that you can't solve, it might be a good idea to try to see if there's a power series solution. Okay, this works in a lot of cases. For example, even with certain derivatives with non-constant coefficients, you can use this to find a solution. But anyway, let's stick to this example. Say that f of x equals some function of x where we just take a bunch of coefficients and then powers of x. And let's start at 0 to infinity, so we get a power series. And I guess we're centering it at 0. You could try to center it somewhere else. But it would be harder to then get this. But anyway, so because we know what we want at x equals 0, something to be 1. When we plug in 0, we want everything to go away. So actually centering it at 0, meaning if we did like x minus 5 to the end, that would be bad. It would just make this harder. So, but we're just guessing, and this seems like a good guess. So what is this? Informally, it's a 0. And it just goes on forever. It's an infinite polynomial. Okay? Well, so I'll write, since f of 0 equals 1, then this implies that a0 is 1. Okay, so we've made a discovery. This should be the number 1. Okay, so now we have 1 plus a1x plus a2x squared plus a3x to the third plus a4x to the fourth. How did we get 1? Well, we plugged in 0. This goes to 0, 0, 0, 0. Everything will go to 0. The only thing that remains is this, but we said this should be 1. Okay, so we have solved for a naught. Okay. Now, what about all these? We need actual numbers. If we're going to do computations, we can't have these infinitely many unknown variables. So that's where we'll go back to the differential equation. F prime equals f. Then observe, well, what's f prime? What's f prime of x? Well, take the derivative of this thing. So 0 plus a1 plus 2a2. Oops, 2a2x. Okay. Now, we want this. We want that this equal to f of x. But what was f of x? It was 1. Sorry, let's shift it over. 1 plus, well, a1x, a2x squared. And so we just observe that, look, this forces a1 to be 1. And then that's going to force these things, and then force and then we're going to get infinitely many equations. And I think we'll be able to solve infinitely many equations. Solve infinitely many equations for the infinitely many variables, unknown coefficients. So a1 has to be 1. That's what this says. Let's look here. Well, a1 is 1. So a2 has to be 1 and then divide by 2. a3 has to be divide by 3, and it has to equal a2 divided by 3, but we already know what a2 is. a2 is a half, so it's 1 over 3 times 2, which is 1 over 3 factorial. And then a4, let's look here. Since 4a4 is a3, well, then a4 has to be a3 divided by 4, but we know that a3 is 1 over 3 factorial. So this is 1 over 4 factorial. And you see that, etc., etc., an is 1 over n factorial, and f of x is now equal to the sum of x to the n over n factorial from n equals 0 to infinity. In other words, 1 plus x squared over 2 plus x to the third over 3 factorial plus x to the fourth over 4 factorial. I could put a factorial here too. Plus I could even put a 1 factorial down here and a 0 factorial down there, because those are defined to be 1, but I won't. Forever and ever. Okay. Wonderful. We found the power series. It is. This is a function. It sends the number x, the power series function sends the number x. Maybe it's a real number, in which case we would get the limit of the partial sums of this sequence would be, again, a real number. Or we could plug in a complex number, and then this might be a complex number. And this started at 0. Okay. What if f of 0 was 5? Well, then this would have been a 5. So you're going to have to think about this one. I'm going to leave this one to you. I'll tell you, you'll have to briefly explain why the answer is this. Then we get 5 e to the x, or 5x of x, or 5 times the sum of x to the n over n factorial n equals 0 to infinity. Okay, in other words, we just get, right, what is this thing? This is e to the x. That's what people mean when they say e to the x. They mean this limit of the sequence of partial sums of this power series. This is what people mean when they say exp of x. And just 5 times that is what happens if we require that f of 0 is 5. And that's it. In fact, this exact same method can be used to solve many problems. Where could it fail? It could fail if you're unable to solve the infinitely many equations and infinitely many unknowns. But it's worth a try. Maybe you can solve them. We were able to here.